Good morning, everybody. My name is Caden Mariner. I am the student project manager for this project. Our project is the Kincaid Park water supply improvement, and I'm joined presented today by Maya Wall. And in the crowd, we have Isaiah Mojin and Blanca DRVZU. Shout out to our professional mentors, Tim Shepard and Christy Main, and our faculty advisor, Professor Deb. So for this presentation, we're going to talk about the project, what it is, where it is, why it's important, and then we're going to take a look into our alternatives and why we chose those, and ultimately the one that we will be recommending to the Nordic Skiing Association of Anchorage, and then finally close out with some lessons learned throughout this semester. So I'm going to pass it off to Maya to get us started.
Okay, so we have currently been asked by the Nordic Skiing Association of Anchorage to make improvements to their water supply. They've been having a little bit of trouble with their snowmaking capacity being insufficient during low snow years due to just variations of Alaska winters. Our goal is to increase their water supply so it can be, their snowmaking systems can be more reliable for them to make it function throughout the recreational season. Our products for this capstone have been a design study report and a geotechnical report. And then on the slide as well is just some news articles about snow scarcity in Anchorage throughout the years. This slide also shows snow scarcity and snow accumulation throughout the night, going back from the 1950s to now. Just like you can see that there's low snow years, high snow years. This means that for NSAA, they would have to so during low snow years, they're working their systems more to so they can ski, so they can snowboard. And then in high snow years, they would be working a little bit less. Our project location is located in Kincaid Park by the airport. The picture up here shows their snowmaking area. Their snowmaking area is that kind of white dotted line. They're currently only functioning with 10% of their overall area of trails. This is because of their water supply. If they could get more water supply, then they would be able to open that up, make it a bigger snowmaking area to produce more snow during the winter recreational season. And this is what we're trying to really fix, to make a bigger area, more snow, longer season. More about Kincaid Park and what they're functioning with, what supplies this water, is two groundwater wells located a little bit kind of downstream of the Kincaid Park. The combined well capacity is about 170 gallons per minute, while their pump house that distributes all this water to the park is 500 gallons per minute. Our job is to close this gap so we can get closer to that 500 gallons per minute. They can have more functioning snow systems and snow infrastructure, because they have the infrastructure, they just don't have the water supply. More about those wells is that they are steel case wells. The casing is just kind of helps the well integrity when it's drilled. And they currently have 2 screens placed in them. The screens just help filter out sediment through, so sand and gravel, what have you, don't get into the pumps, because that would be bad and damage the pumps. Originally, they only had a core screen being put into the wells, but then they realized that they were still getting sediment accumulation and they needed to add a second screen, so that fine screen. The well development for these 2 wells is currently air surging, which pushes air through the screens, which leads us to believe that clogging of the screens isn't necessarily the problem when it comes to getting more water out of these wells. Our alternatives that we considered for this project have been alternative 1, which is a no build, alternative 2, well rehab, alternative 3, well expansion, and alternative 4, which is a water main extension going from either 4A, Raspberry Road, or 4B, which is Kincaid Reservoir. For our no build alternative, we would just be leaving conditions as they are, which won't necessarily expand, would not meet NSAA's needs. I mean, well, wants for Kincaid Park, and won't really provide them to, expand for future recreational activities. Well rehab, however, the possible options for rehabbing your well include replacement of the fine screen, building a combined filtration system, or chemical and mechanical cleaning. With the first two that are listed here, replacement of the fine screen and a combined filtration system, we learned that by just talking to certain drilling and well contractors, that they don't really prefer to, like, once the screens are placed in the well, they prefer to keep them there, because removing that screen can cause damage to the casing, can cause damage to the well. So that's why we're not really recommending, we're not too much of a fans of the first two. But chemical cleaning, however, if NSAA were to chemically clean the wells, then we would recommend that they use an acidization treatment, which has the potential to get the wells back to their original capacity before they had that kind of sediment issue and before they had to place the fine screens in. Well expansion. So as our background kind of explained before, they're currently running on 2 wells. And we believe that if they were running on 5, so drilling 3 additional wells that are exactly like well 2, which well 2 was drilled deeper, more into the aquifer, and produces majority of the water. So it led us to believe that if they were to drill like that 3 more times, then they could reach their 500 gallons per minute. A picture here is just shown about how water wells interact with kind of the water table that's under the ground surface, and how draw down and how it interacts when it's pumped. NSAA actually has a plan to place piezometers or monitoring infrastructure inside their wells to kind of monitor how the aquifer is changing when they're pumping these wells and pumping water out of these wells. This is really beneficial because with wells, you really need to learn about the aquifer recharge rate, like how is the aquifer, the water table, replenishing after you've been pumping it for however many hours? What's the drawdown? Like, what are the losses when you pump it for this many hours? How much is it going down? So with this alternative, there's still a lot of things that need to be explained, a lot of things that we still need information on, because we just don't know what that water table is doing and how it's interacting with the environment around it. So yeah, it's very dependent on the water table. And now I'm going to pass it over to Caden to explain alternative 4.
Yeah, thank you. So we have been looking at 2 alignments for an extension of the Anchorage water and wastewater utility mains. They were chosen just by location and ease of constructability. So yeah, our 2 alignments here, the first alignment in the yellow follows Raspberry Road for its entirety before it shoots up into the existing pump house, which it would connect right before the high pressure pumps in that pump house, which then distributes the water at a high pressure to the existing infrastructure and the snowmaking fan guns. And then our other alignment there starts at an existing Kincaid reservoir. It's a large above ground water storage tank. And that would attach to the distribution pipes coming out of the reservoir, cross through a little bit of section of trails, and then cross completely underneath the road and follow the same alignment as the yellow one for that section. And the Raspberry Road alignment is about 1.75 miles, and the other one is 1.25, so a little bit long, or a little bit shorter. That was a little shorter. Here's just a closer look. We're going to look at both alignments really quickly and their profiles that go along with them. This one, the longer one, has an elevation gain of 130 feet, so decently substantial. And we found out through some calculations that a booster pump is required to be able to boost the pressure from the existing pipe on the right side there to the pump house. So a booster pump is pretty expensive. So that's something we looked into in the cost estimate. Whereas for the next alignment, the elevation change here is only about 30 feet. So no booster pump needed. It's shorter. And it would ultimately cost quite a bit less, we found out. So go to the next one. So for our pipe materials, we're deciding between these two, ductile iron and PVC. These are the most commonly seen pipes around the Anchorage area. There are so many more pipes that we briefly looked into, but we chose these just for their convenience and accessibility in Anchorage. After looking at the pros and cons of both of these, we decided to recommend PVC to NSAA, primarily because of cost and also looking at geotechnical reports and investigations in the soil. We found out that the soil is pretty moderately susceptible to corrosion. So putting some heavy, beefy iron didn't make a lot of sense because the Raspberry Road is a pretty lightly trafficked road. It's not a main road where you need a really intense pipe. So something to consider about PVC is you might need a little bit more bedding material, which is the sand and gravel that you put underneath the pipe and around the edges of the pipe to be able to support it, so that the PVC, a little bit more weak of a material, doesn't flex and kind of mushroom under the loads of the soil and live loads of the road on top of it. So this is how we chose our pipe diameter using some equations, Darcy-Wadsbach and Colbrick equations. We were able to determine that using PVC, 10-inch diameter pipes is the minimum required to be able to supply Kincaid and NSAA with flows greater than 500 gallons per minute. This meets AWU's requirement of having a pipe of at least 8 inches. And 10 inches is not a common size, but it is frequently used, and AWU would be able to get its hands on plenty of 10-inch pipe PVC. So this is our weighted evaluation matrix. We asked NSAA, and we as a company ranked all of these costs on a scale of 100%, and compared those to how likely each alternative would be to succeeding in these criteria. So cost, constructability, project-able effectiveness, those carried a lot of weight. And comparing those, we have determined that the alternative 4B, the water main extension from Kincaid Reservoir, is the one that we'll be recommending. And I'm going to pass it right back off to Maya, and she'll close this out.
Okay, so this was a really rewarding project for all of my group members. It was really rewarding for me to be able to work with them. And I think what we learned the most is just time management, how to come together to actually be productive and work on our assignments and, you know, to complete this. And I think a second thing that we learned is public speaking improvements, besides, you know, me forgetting how to say moderating because what? But I swear I got more confident speaking, and I swear this is good practice. And organizing communication between our client and our mentors and us, just because it's really like interesting to work with people from different backgrounds. Like my team is like soon to be engineers, then our mentors are actually like working engineers, and then NSAA is just people who love recreation. They're not engineers. So learning how to like kind of translate our language to their language and work with them, because we all have a common goal of just living in Anchorage and wanting better for Anchorage, wanting better for their community. So in that, having a common goal was nice, but translating can be a little bit difficult. Consistency with scheduling and due dates. This project had to be done between the months of January and now. So that was kind of intense because we did go through like kind of a slump of just like, what is a water main? What do we need to do? What water? Where are we going to get it from? So just having like that kind of getting over that hump, getting over that learning curve, and then being able to talk to NSAA about what they wanted to see, what they wanted to hear, and then talking to our mentors about, how we're going to do this. I think that effort really, really, is what made this project. So that leads me into our thank yous to our mentors, Tim and Christy, to our faculty advisor, Professor Dev, to my teammates, because they were really helpful keeping me on track, to NSAA for just providing us with a great project, to the College of Engineering for providing us with this class. But yeah, so thank you. And any questions? Okay, so the question was about Kincaid Reservoir. Who else is using that water? How are we going to supply that water to Kincaid? I do believe that the Kincaid Reservoir is currently servicing just a small neighborhood. And I do believe, so it's currently serving a small neighborhood. And I do believe that with like creating like an extra kind of distribution pipe that would go to Kincaid Park, I do believe that there is enough water in that reservoir to provide that. Exact numbers we can provide you with later, but I do think that we checked with AWU, and yeah, so they're just currently servicing like a small little neighborhood, but have the capacity to service more. What's up? Okay, the question was, do we have a life expectancy for PVC pipe? And did we look into any environmental impacts of the degrading of PVC pipe? Kaden, what do you have to say about that? And then I'm gonna pass it to you. You pass it back to me. I'll pass it back to you. Okay.
We did not look into the environmental impacts of degrading PVC. No, mostly just cost was like our main goal for the scope of this project. No, yeah.
I have a couple of things online.
What?
Are you able to hear me?
Yeah, we're able to hear you.
Hi, this is David Persinger, General Manager of Anchorage Water and Wastewater Utility. I don't have any questions, but I want to share my gratitude to you for taking on this project and bringing it to the point you did. An excellent presentation, excellent report, and I'm very hopeful that we can see this come to fruition sometime in the future. And I hope that your experience in the water and wastewater world as part of this project helps inspire you as you enter into the workforce. And we're always looking for engineers in the water and wastewater field. So keep us in mind, please.
Oh, thank you. Thank you. It's great to hear that.
Thank you very much.
Yes. Oh, answering the question I had, yes. Yes, and that's why he's our mentor. Thank you. Yes.
On the connecting to AU service, was that considered as part of your guys' cost estimates? Now paying AU for their service?
So the question was did we include in our cost estimate the kind of maintenance that NSAA would have to provide AWU? I believe for our cost estimate, it was just like, what is the cost to kind of construct and kind of go about constructing? So yeah, it's just cost to construct and not necessarily maintenance.
Could you repeat the question just one more time?
Yeah, the long-term cost to NSAA, if that was considered, that they connected to a service. And then if they were to go one of the other options, like adding more wells, they have to make it cost of that.
Yeah, so if NSA goes with the water main, AWU fronts all maintenance costs, but if they drill their own wells, they have to maintain and take care of the wells. So
Did I answer your question? Perfect. Yes.
So that's something that would have to be decided. We do have both unmetered and commercial type clients. I'm leaning towards the close it would probably still get higher rate. But depending on, because they have a high season and a low season, it makes more cost effective to actually just irrigation. So plus it would be easier at that point too. They handle snow during winter, but it's also Kincaid Park and NSAA Park Department that actually do the irrigation in the summer. So easier to get the proper people shipping in.
Any more questions, guys? What's the burial depth of the water main? The depth is 10 feet, at least has to be 10 feet. Yeah. Any other questions? Perfect. Well, then I'll hand it over.